Alright, in this video we're going to talk about the Pythagorean Theorem. We're first going to briefly talk about where it came from to try to understand how it works, and then we're mostly going to focus the entire video on just using it to find unknown side lengths and right triangles. So as a brief note, I'm already going to mention this technique is only for right triangles. For triangles where one of their angles is 90 degrees, and it will be shown by that little box in one of the corners. That's how you know you're dealing with a right triangle. That's the only kind of triangle that in general that the Pythagorean theorem works with. Alright, so in short, here's what Pythagoras found way back in the day when the Greek philosophers were the ones doing all the math. He found that there was actually a relationship between the side lengths of the sides of a right triangle. So for example, let's use the one we have right here on the left as an example. If you have a right triangle, the side length is 3, the side length is 4, and this side length is 5. Now, if you do this, he found that if you make each side of your triangle into a square that has that length, so if this has a length of 3, the square has a length of 3. Well, if it's a square, we know if this length is 3, this length is 3. So the area of that square, there's a total of 9 square units inside that square. So he found that if you do that for every single side, turn every single side into a square. So this one is 4 by 4. This one is 5 by 5. Here's what he found. If you took the area of the two smaller ones, later we now call these legs, but I'll get to that. If you take the area of these two smaller squares, he said that they will always add up to the area of the biggest square. And he said that he had to find that pattern. He tested it. He realized it's always true. He couldn't find an example where it wasn't. So the area of these two squares is added together. So now for this square on the left, this triangle on the left, if this is 4, this is 4. So the area of this square is 4 times 4. That's how we got the 16, or you can just count. Or that's also known as 4 squared. And this one down here is 3 times 3, or just call it 3 squared. And then this one was 5. This square was 5 by 5. So just like any rectangle or square, to find the area, it's length times width. Well, if the length and width are the same thing, it's just going to be 5 squared. So the area of that one is going to be 5 squared. 5 squared is the area of that one. So now, let's say we didn't have numbers. Let's say we want to make a general rule, which a lot of people know what the Pythagorean theorem is. Or maybe you're seeing it for the first time. And that's perfectly fine. This is a very popular, famous rule. Let's say nothing but letters. Let's say you had a right triangle and the side lengths are A, B, and C, where A and B are the shorter two, and C is the longest one that's across from the 90-degree angle. Didn't mean to erase that. So now, if that's the case, the area of this square, it's going to be A units this way, A units this way. So A times A. Well, A times A, that's A squared. So the area of this square is A squared. This one is B units this way and B units this way. So B times B, that's B squared. This one's C by C, or C times C, which is C squared. And so just like we talked about over here, if you add the two smaller squares together, in this case A squared or square A, or B squared or square B, if you add those together, it'll equal the biggest square, square C, or in this case C squared. So this is where the relationship came from, where they found the Pythagorean theorem. This is an experiment of proving that it's true for just one specific triangle, but it's always true, and this is the rule summarizing what we're saying. So this is where it came from. I just want to take a moment to show you where the Pythagorean theorem came from, because that sometimes gives you a deeper knowledge where you can understand they didn't have a bunch of technology when they did this. They just did it through trial and error and process elimination and with the scientific method of testing things and thinking about them. So now we're going to focus the rest of this video on actually doing it, using it to solve for side lengths. I'm not going to really talk about the proof of it anymore. We're only going to focus on how to use it. Okay, so now we're actually going to work on doing some examples of using the Pythagorean theorem to find the missing side lengths of right triangles. That's what we're going to use it for. Now this can be used for real world problems, finding indirect heights, measurements, lengths, distances, stuff like that. It can be used on maps. It can be used for finding distances in the air, all kinds of stuff. But in the beginning, we're just going to focus on keeping it with simple triangles. In the beginning, we're not going to apply them, and then we'll do a few where we are. Okay, so before we go anywhere, we got to establish some vocabulary. What I want you guys to see is, let's take a look at this example right triangle up here. There's a few words we need to make sure we know. You need to know what a leg is. On a right triangle, the two sides that are next to the right angle, those sides are called legs, the ones that are next to the right angle. So every right triangle has two legs. The side that is across from the right angle, that side is the hypotenuse. It's kind of a silly sounding word, hypotenuse. That is the side that is across from the right triangle. Notice the hypotenuse is the one that will also be the longest side of your right triangle. Because it's across from the biggest angle, it will always be the longest side in a triangle. So in any question, the longest side should always be C, or the longest side should always be the hypotenuse. That brings me to my next point. C should always be your hypotenuse. You cannot get that backwards or mislabel it in your formula, otherwise it will not work. So C must be the hypotenuse. Fortunately, A and B, you can get those backwards. That will never change your answer. It doesn't really matter which leg you call A and which leg you call B. It'll never change your answer as long as you make the legs A and B and the hypotenuse is always C. So the legs can be backwards, it does not matter. For example, in this problem down here, they actually call this leg B and call this one 8. So I would make this A and they're apparently making this one B. So I'd make this C. Technically, you could call this B and then call this one A. Even though they're not calling it that, you would still use the formula and get the correct answer for that missing side link. So it could still work. So just know, as long as you make the legs A or B and then the hypotenuse is C, you're always going to use this formula for every single question. Now further, lifeguard perspective for a moment. Every single question you have using the Pythagorean Theorem, you will always have, or you'll need to find, 2 of the 3 sides. So they would give you these 2, or they could give you these 2, or they could give you these 2. They'll give you 2 of the 3. So there's only 2 types of questions. There's only 2 types of questions. I know we just said there's 3 combinations, but really there's only 2 types of questions, because no matter which, if they're missing leg A or they're missing leg B, it doesn't matter. When you go to do those questions, they solve exactly the same. So there's what I call a leg type of question, where you're looking for a leg, and then there's a hypotenuse type of question, where you're looking for the hypotenuse. So all questions where you're looking for the hypotenuse, they will all solve exactly the same way. All questions where you're solving for the leg, they will all solve exactly the same way. So that should give you perspective, that should give you comfort, knowing there'll be no surprises in terms of how it sets up or what steps you go through in order to solve it. So that's what we're going to do. We're going to do a few examples of each. I'm going to try to do 2 examples of each. We're going to start off with 2 hypotenuse looking for questions. Then we're going to do 2 questions where we're looking for the leg. We're going to do 2 of each, and then I'll try to do some word problems, maybe 1 or 2. And then I'm going to set you guys free. You can go home and practice it on your own. So let me press pause real fast. Make sure you jot down these notes maybe as a reminder so you know you have them. These are some of those core ideas you want to keep track of. Obviously, especially the Pythagorean Theorem itself. That's one of those theorems, one of those rules, formulas, you're probably going to memorize. But in the beginning, it might seem a little weird, but we're going to practice this until this becomes second nature so that you never hesitate. You always know, no matter what, you know how to set up and how to go about it. So you want to get to the point where there are 0 surprises of using this concept. Because you're going to see the Pythagorean Theorem in Algebra 1, pre-algebra, you're going to see it in geometry, Algebra 2, you're going to see it in trigonometry, definitely. You're going to see it definitely pre-calculus. It's used to prove some trig identities in trigonometry. It's one of those concepts that never goes away. It is a very powerful tool, and it's one that is relied upon for other scenarios as well. So this is one of those skills you're going to see for all of high school. So lock it in now so that later it's cake. You don't get hung up on it. It's kind of like when you learn how to add, subtract, and multiply, divide with negative numbers, or even fractions. Once you know the rules and you know them, you believe in them, there's no questioning it. So then they're just a tool in your toolbox that are always ready to go. All right, let's get this thing going. Okay, so in each of these questions, we're going to do the ones I have on the screen, and I have them in a slightly different order. We're going to start up here with number 1 on the top left, then we're going to go to the bottom right for number 2. So I want to do 2 questions that are the same type first. So now, before we go anywhere, I want to show you what I mean by there's only 2 types of questions. And you'll also see what I mean by us doing them, seeing that the steps are the same. So here's the first thing we're going to do. Let's identify what types. In number 1, you know this leg. You know this leg. You know their leg because they're touching the right angle. That means you're missing this one. That means you're missing the hypotenuse. So this is a hypotenuse type of question. This is a question where you're looking for the hypotenuse. This is the easiest of the two types in the beginning, but after a while, it won't matter what type they are. You'll be able to do them. Now let's go to number 3 over here. And number 3. In this one, you know the side across from the right angle. You know the hypotenuse. You know this leg. Oh, but you're missing this leg. So in this one, this is a leg type of question. This is I need to find the length of a leg. That's a leg type of question. That's how it'll look. Now, it doesn't have to be A. This could have been B and this could be A. It truly does not matter. Now, number 4. Let's go to number 4 over down here. In this one, we know the hypotenuse because it's across the right angle. We know this leg, we're missing this leg. So number 4 is also a leg type of question. Now, when you go over to number 2 over here, in this one, we don't know the hypotenuse, but we do know this leg and we do know this leg. We're looking for the hypotenuse. So that means number 2 is a hypotenuse type of question. Number 2 is a hypotenuse, what I call a hypotenuse type of question. So there's only 2 types of questions you could possibly have with the Pythagorean theorem. So now we're going to work through each of these. We're going to take our time. We're doing two examples of each. So you can see no matter what's missing, a hypotenuse or one of your legs, it truly doesn't matter. And to show you that which leg is which doesn't matter, I'm going to change this one to B up here to show you, even if it was B, if that was called B up here, it doesn't matter what it's called. So even if we call it B, it's still going to set up and solve the same way. So let's get on the road. We're going to do number 1 and number 2 and then 3 and 4. All right, so now for number 1, your first goal is to plug it into the Pythagorean theorem. So that's what we're going to do. We have 2 legs. I told you earlier, it doesn't matter which leg you call A or B. So 32 can be A or 20.3 can be A. So I'm just going to start writing. So let's see. We're going to make this one A. We're going to make this one B, which makes this one C. And they're actually already calling that one C. All right, so we're going to start by setting it up. So A squared plus B squared equals C squared. A is 20.3. So that means we have 20.3 squared plus 32 squared, since that's A and that's B, equals C squared. And C is just C squared. That's how this question sets up. We now are ready to go about solving it. Now, to solve for C, we gotta get it by itself. Well, it's already almost by itself except for that squared. So let's simplify this side so we can finish getting C all the way by itself. Order of operations. Before we can add these together, we need to do the exponents first. Exponents come first, so we have to square first. Now, there's no shame. This is the part where your calculator comes into play with numbers like this. Now, when they give you smaller numbers, yeah, you should be able to try to do some of those in your head, but there's no shame needing to do 20.3 squared. So if you square 20.3, meaning 20.3 times 20.3, you get 412.09. Now, do 32 squared. 32 times 32, well, that's 1,024. All that equals C squared. C squared goes nowhere. Now, what you're going to do, you're going to just go ahead and add those together. Because at this point, we need to simplify that one side as far as we can go. So 1,024 plus 412.09. Okay, that gives us 1,000. You could have done this one without the calculator. 1,436.09. All of that equals C squared still. So now we're at the final step. We're at the step where we're ready to get C by itself all the way, meaning, can I get rid of this squared? So if you remember your squares and square roots like we talked about in previous videos, the way to cancel out a square, or the opposite of squaring something, is to square root it. So if you square root both sides, you're going to cancel out that squared on the C. So the square root's going to cancel, the squared's going to cancel. So you're going to be left with just your C. So you're going to have, I'm going to write it right next to it over here. You're going to have C equals, now it's just time to get the square root of that big old giant number on the left. So if you get the square root of that, remember it's going to be a non-perfect square, so it's going to be a rational number, but just write a few of the digits so you can round them appropriately. 37.89. And if this question said, I believe the instructions probably said something along the lines of rounding to the nearest tenth, the 8 is in the tenths location, so the 9 tells you to round up. So that means this is going to round to, because technically that one was rounded to 2. So this is going to say C is approximately equal to 37.9, and our question was in inches, so 37.9 inches. That's how long C was. 37.9 inches approximately. That's how we find that missing value. So to quickly summarize and recap, what we did was we plugged in for A, B, and we didn't know C, so that one stayed C. Square everything, no matter who it is. Square A, you got the number here. Square B, you got the one below it. C, we don't know, so we just leave it as C squared. So square everything. Then your job is to combine all the constant numbers that you can. Everything on the left can be combined. So add those together. You've now added them together and you have C squared. Now your job is, your final step, no matter what type of question, is to do the square root of both sides to get the letter by itself. So the square root of this is what gave you your value for C. So that's how you found this question. So this was a hypotenuse type of question. A question where you were looking for the length of the hypotenuse of the right triangle, meaning the longest side. Okay, now let's go to number 2. If you think you understand that process real fast, even if you're not quite sure, at least start number 2 on your own, press pause, give number 2 a shot, and then hit play and see how you're doing. Okay, so hopefully you hit pause and give that one a shot. Now let's actually take a look at it. So now in this question, we can call either of these A or B, it does not matter. So I'm going to call 14A and I'm going to call 6.7B. That makes the hypotenuse C. We're missing it. So let's set up this question and solve it. That's what we're now going to do. So let's start with doing A squared plus B squared. Well, A is 14. So that means we have 14 squared plus B is 6.7. 6.7 squared. We don't know what C is, so we're just going to leave it as C squared. Now, your job is to go through and square everything that you can. That's the first step, no matter what kind of question it is. So 14 squared, well that's 196. So 196 plus 6.7 squared. Oh no, it's a decimal. Doesn't matter. Do 6.7 times 6.7 and you get 44.89. We don't know anything about C, so it's still C squared. As of this step, you're now going to add everything on the left side that you can. So the 196 plus the 44.89. And that's going to come out to 240.89. All that equals C squared. So now it finishes like all questions. You're now just going to square root both sides to find out what C is. Remember, you always get rid of a square by square rooting. Just like adding gets rid of subtracting, multiplying gets rid of dividing, and vice versa. The same thing goes for squares and square roots. So you're left with C on the right side, and on the left side, the square root of 240.89, 240.89, okay, is an irrational decimal, but we're going to just write a few of those digits, 15.52. Now to round to the nearest tenth, we're going to say 15.5. 15.5 millimeters. That's how long the missing side is in number 2. That's the length of the missing hypotenuse. So one more time, plug in A and B, square both of them, add them together, and then take the square root of both sides and you have your answer. Then just round accordingly based on what the instructions say. And sometimes you don't need a round. Sometimes they'll give you perfect squares. And that's very nice of them when they give you pretty numbers like that. So that was now 2 examples of hypotenuse type questions. Now set that skill slightly aside. The next 2 we're going to do start off the same, they finish the same, they just have one step in the middle that's a little different. So when we go to do numbers 3 and 4, pay attention how they're slightly different. But if you think you have a hunch of already how to set them up and solve them, yeah, go ahead, hit pause, give them a try first, and let's do that. Alright, so let's go to number 3. Number 3. We said just for the sake of showing you it doesn't matter whether it's A or B, I made this one B, so that means this one's A down here. So that means 3 yards is A. That's what that means. So to set this up, we're going to do A squared plus B squared. Well, that means A is 3, so that means it's 3 squared plus B squared. B squared is just B, we don't know what it is. And C is, and we know C for C squared. C is 2.7. So 2.7 squared. Now notice here, in all of our past questions, we had C over here. That's no longer the case. So now when we go to square, we're actually going to square this side as well. But this one is just going to stay B squared. So let's do 3 squared first. 3 squared, well that's just 9. B squared, that's just B squared. We don't know what B is. Now 2.7 squared, just like I said earlier, it's a decimal, doesn't mean anything. Do it by hand, use your calculator, whatever you need. Do 2.7 times 2.7. And you're going to get, the equal sign drops down, don't forget the equal sign. And you're going to get 7.29. Now you're ready to start solving for B. But just like any equation, if you're going to solve for a variable, solve for a letter, you've got to get everything away from it, which means we have to get rid of this plus 9. We got to get this plus 9 out of there, and we do it by doing the opposite. Well, the opposite of plus 9 plus 9 or positive 9 because there's nothing in front of it is negative 9 or minus 9. So you're going to subtract 9 on both sides. I did something silly, I just realized. Okay, guys, so when you look at this question, some of you may be thinking, Mr. Phelps is crazy. So when you look at this, I just realized I set this up wrong. I assumed that this was the hypotenuse from glancing at it, but I didn't follow my own rules. In this question, this is your right angle, this is your hypotenuse, and I just realized that when I realized that one of our sides was longer. Give me 1 second, guys.
Students and staff. Teachers, a reminder, after school comes.
Alright, so I'm actually kind of glad I did that. Hope I didn't waste too much of your time, but here's why. I want to show you guys that what we were just doing, how you kind of know if you're identifying these incorrectly. So I did it on accident, but it's kind of fortunate. Is you notice this is actually my hypotenuse over here. 3 should have been C, so 3 should have been way over here. But if you'd gone through this question, right as I went to go show my work, 7 something minus 9, that's a negative number. When you go do the square root of both sides, you can't take the square root of a negative number. That's something you'll talk about in Algebra 2 and you learn about numbers that don't exist. But for now, you can't do that. So you would have gotten an error and you would have been confused scratching your head. It wouldn't have worked. So go back and use your base assumptions may have been wrong. You got to realize the side that's across with 90-degree angle, that's your hypotenuse, that's C. And so when you got an answer that makes sense, maybe take a moment to consider your base assumptions, which side was which, and double check that. So that means this question actually is not a leg type of question. Oh no, it is a leg type of question. I just labeled them backwards. So my A and C, they're switched. So so it's still a leg type of question. We're still looking for the leg, but I just happen to switch A and C. So what we're gonna do is we're gonna switch those back. All right, so let's set that up one more time. So it's still a leg type of question. We're still looking for the leg, but I just named them backwards. So that means this is gonna be C and this is gonna be A. So let's try that one more time. So we go to set this up, A squared. So that's gonna be 2.7 squared plus B squared. We don't know B, so it's just plus B squared. Equals C squared. Well, C is 3, so it's 3 squared. Everything else I said still stands. You're gonna have a number over here that you can actually square this time around to help you do that. All right, so like we said earlier, 2.7 squared, well that's 7.29. B squared is just B squared. 3 squared is 9. Now it makes more sense, because now when we go to subtract, it's for the same reason we said earlier, to get rid of plus 7.29, we have to subtract to get rid of 72.9. It's gonna be the same thing. All right, so we're gonna subtract 7.29 from both sides. That's what we're going to do. So it's going to cancel on the left side, and so now we're going to be left with B squared equals 9 minus 7.29, that's going to be 1 point something, 9 minus 7.29, oh, 1.71, okay. All right, so 1.71. So at the end of this step, you'll see it now finishes just like our hypotenuse type of questions ended. We're left with something squared equals a number. So we have to get rid of the squared. So the two types, this is where they're similar. They start off the same, plug in for what you know. The only difference is this middle step. In this one, we had to subtract from C squared. But they all finish the same way. They end with something squared equals a number. So your last step for both types of questions is always going to be to square root both sides, because that's how you get rid of a squared. So we're going to be left with B equals, now the square root of 1.71, that's going to be our answer. The square root of 1.71, just to write down a few of them, that's going to be 307. So now, if we round that to the nearest tenth, we look at the 0. The 0 tells us to round down, so that rounds down to 1.3. So that means B is approximately equal to 1.3 yards. And that's going to be the length of the missing leg or the missing side in question number 3. So that's our first example of a missing leg type of question. So take a moment to think about that and see if you understand that, and then apply that towards number 4. So press pause for a moment and give question number 4 a shot, and actually take your time and set it up just like that top one, but this time subtract the leg squared, the known leg squared from C squared, from the hypotenuse squared, and then take the square root. Try that and hit pause and give it a shot and hit play and see how you did. Alright, so you should try this number 4 first. Make sure you try number 4. Alright, so now let's set everything up. A squared plus B squared equals C squared. A is just A. We don't know what A is. So we're just going to call A a squared. Well, we know what b is. B is 6, so that means plus 6 squared. And the hypotenuse is 11.2, so it's 11.2 squared. So just like every other type of question, your first thing you're going to do is square everything in sight. So let's start with the tough one. Let's do 11.2 squared first. It doesn't matter really which one you start with. Now that's 125.44. Now the other one shouldn't be too bad. 6 squared, 6 times 6, 36. So a squared plus that. So now we have a formula. We have to solve for a. We have to get rid of plus 36. Well, like we said earlier, you get rid of adding something by subtracting it. Excuse me, guys. Okay, so we're going to subtract that from both sides, and so it's going to cancel on the left side, and then we're left with a squared. So you've got a squared equals, now just see what the right side equals, 125.44 minus 36. And that leaves us with 89.44. Just like every other question, you got to finish by taking the square root of both sides. The square root and the square, they cancel out. And so we're going to be left with a equals about 9.45. Got to round to the nearest tenth. So a is approximately equal to 9.5 meters. That is the length of the missing leg or the missing side in this right triangle. So now, we've now done, take a moment to think about that. Hit pause if you need to. We have now done an example of both types of questions. We've done 2 examples of each, of looking for the hypotenuse type of questions, looking and also looking for the leg type of questions.
Now 2, we have Julian.
So now that you have 2 examples of each, you should write these down so you have perfect, clear, concise examples on how to set each of the types up, and take a moment to really think about how the methods are the same and how the methods are different. What we're now going to do is we're now going to do a few applied problems. We're going to do a few word problems, or just applied questions where these aren't just triangles and just on their own. They're actually going to mean something. So it's going to mean more. It's going to have more application to the things around us. Okay, so let's take a look at this question. This is a word problem. It's in context of a question. We're going to use what we just learned about the Pythagorean Theorem to solve for things in this scenario. It says, in a computer catalog, a computer monitor is said to be 19 inches. Then they tell you the way that monitors and TVs, for this matter, the way that distance is disclosed and the way it's measured is this distance is the diagonal distance across the screen. Meaning, if this is your computer monitor and this is the screen of it, the distance that they're reading you, that they're telling you, is actually the distance from the corner to corner. It's that diagonal distance across it. That's the measurement they're giving you. Now, this used to be a really honest, as a side tangent, this used to be a really honest measurement when we had square televisions, because that diagonal is directly related to the height and the width of a square, since they're the same. But now that we have widescreen TVs, widescreen monitors, things with different aspect ratios, that diagonal measurement isn't always the most clear for that, because now it might always make sense. Okay, so as I was saying, the diagonal measure for square is an honest determination of how much area or how big that square is. But now that we have TVs with different aspect ratios, I exaggerated with these two where they're really long. That diagonal measure might not be the best. Alright, but that's the standard. We're just going to stick with it. So sorry for that tangent. Just wanted to put that out there concerning TVs. Anyways, back on track. It tells us that it's 19 inches. So that means out of a computer monitor, we know that this monitor is said to be... Okay, so what our job is, it's going to be a widescreen computer monitor. That's what they're telling us. It says, if the screen is 10 inches high, what is the width of the screen? Meaning it's implying they're not the same. So it's not a square. So this is what you guys are used to seeing these days with rectangular widescreen screens. Alright, so anyways, that diagonal distance is 19. So that means that distance across it is 19. And if it's a rectangle, because it's a screen, this is 90 degrees right here. And so is this one. In fact, all 4 of those corners are 90 degrees. Now they just told us it was 10 inches high, which means the height of it is 10. Or you could say, right, the 10 over there. So both of those are the height. The height of it is 10. The question says, what is the width of the screen? And in other words, they want to know how wide is it. So this side or that side. So in this question, if you drew it visually like I did, you actually have 2 right triangles to choose from. It doesn't matter which one you choose because they're exactly the same size. They both are a height of 10 and a width of, I don't know, with a hypotenuse of 19. So no matter which one you choose, you're gonna be just fine. So I'm gonna trace the lower one. That's the one that I'm gonna focus on, because just so we have one to refer to. So that right triangle is what I'm going to use. We know this leg, we know the hypotenuse because it's across from a 90-degree angle. We do not know this leg. So that means this question is a leg type of question. We are looking for the missing leg in this right triangle. So now let's set it up using the Pythagorean theorem. So a squared plus b squared. Okay, I'm going to make a 10 just because I know what it is. So that means it's 10 squared plus b squared. We don't know the other leg, so it's just b squared. Equals c squared. Well, we know the hypotenuse, c. It's 19, so it's 19 squared. So in this question, this is just like the last two we did, where we're looking for the leg. That's what we're doing. So now, just like all methods, let's start by squaring everything. 10 squared, that's 100. B squared is known as b squared. 19 squared, 19 times itself is 361. Now, just like what I mentioned earlier, we have to get b squared by itself. Got to get rid of plus 100. So subtract 100 from both sides. If you do that, you're going to be left with b squared equals 261. Now, if you take the square root of 261, that's going to be your answer. So let's take the square root of both sides so we can cancel out that squared. So the square root cancels out, the square cancels out. We're going to be left with b is approximately equal to, the square root of 261 is about 16.155. Rounding that to the nearest tenth, we're going to end up with b is approximately equal to 16.5 tells us to round up, so 0.2. 16.2, and we're measured in inches, so 16.2 inches. So the answer to this question, what is the width of the TV screen? We're going to say that the width is equal to, you can use a complete sentence if you want to, the width is equal to 16.2 inches. And that's going to be your final answer for the width of this TV. So notice how this question, they gave it to us with words. They didn't give us the triangle. We got to imagine it and draw what they were talking about and drew it on our own. So we'll do maybe two more examples, but probably only one more. All right, so I decided we'll actually do two more examples. We're going to do one of each type. All right, in this question, we're talking about ramps. Sasha wants to build a ramp that will rise 4 feet. It'll rise 4 feet over a distance of 20 feet. How long will the ramp be? Round your answer to the nearest tenth. Okay, so they gave us the visual already. That was nice of them. So using this visual, if they didn't give it to you, you could draw it on your own. Your 90-degree angle is that moment where the vertical meets the horizontal on the ground. So what's across from that is your hypotenuse. We don't know this one, so that means this is a hypotenuse type of question. In this question, we're going to be solving for what is the hypotenuse. It does not matter which one of these is called A or B, so I'm just going to call this one A and this one B. So now our job is now to just set this one up. So let's write it big and proud. A squared plus B squared. Well, A is 4, so that means we're going to have 4 squared plus B squared. B squared is 20, so it's going to be 20 squared. Equals C squared. We don't know the hypotenuse, we're just going to call it C, or C squared. So now we're set up, we're ready to roll. So if you haven't done so already, press pause and make sure you knock this one out on your own to prove to yourself that you know you're ready. Because that's the point of this. You want to know you're ready, not think you're ready. Okay, 4 squared is 16. 20 squared is 400. Equals C squared. Now add those together, you have 416 equals C squared. Now, just like every other type of question, your last step is to square root both sides in order to get rid of that square. I always say that, I've been repeating this, I want to remind you, because that's the part that people have the most trouble with sometimes, is how to finish that question off. Other than getting it started, of course. We're left with C. Square root of 416 is 20.39. It said round to the nearest tenth, that's why I wrote the hundredth. That 9 tells us to round up, so we're going to round up. So that means we're going to end up with approximately equal to 20.4. So let's put it all together. How long will that ramp be? That ramp will be 20.4 feet. 20.4 feet. That's how long that ramp will be. Now let's discuss this real fast. You'll notice that in this question, your hypotenuse was almost the same size as one of your legs. So you're thinking, well, I thought it was supposed to be bigger. Well, it is, but barely. But it does fit the requirement of being bigger. And the reason why it was only barely bigger is because this triangle was so long. Because it was so long, if this was like a hinge, where this angle is down here, if that was like a hinge, when it opens like that, when it's barely open, they're almost exactly the same size. Exactly right. So in other words, it is perfectly reasonable if the hypotenuse is just barely bigger than one of your legs, as long as you have a really skinny triangle like that. So in this question, we had a hypotenuse type of question. I just want to do one more of that one. And because leg type questions are the hardest, I am going to do one more leg type of word problem. Leg type of question. We're looking for the leg. And if you don't think you need more help with it, you can hit the in the video now. It's up to you. But I am going to do one more using a leg type of question. If you've stuck with me this whole time, I think you're starting to get a really good idea as long as you've thought about these, participated, written them down. I think that you're getting towards the point where all you need at this point is just some practice on your own to really lock it in so that you really can trust in the Pythagorean Theorem. Alright, so we're going to make this our last example. And I believe that would make this one question number 7. We did 4 plus 2, 6. Yeah, so I think this one's going to be question number 7. Alright, so question number 7. As a reminder, let's get that Pythagorean theorem written up there. Hopefully you've got it memorized at this point. A squared plus b squared equals c squared. Now I've already given the way this is going to be a leg type question, but just to make sure, let's check on our own. We see that this is a 90-degree angle here. This side is next to it, this side is next to it, so those are the legs. This is the hypotenuse. We know the hypotenuse, we're missing one of the legs. So this is what I've been calling a leg type question, meaning we have to find the leg. This is one of those 2 possible scenarios. So let's go about setting this one up. Let's call the one that we don't know, let's call that A. Let's call the one that we do know B, those 2 legs, and so that makes the hypotenuse always C. It's always C. You have no flexibility with the hypotenuse, but you do have flexibility with the legs. Okay, so let's set this one up, write it big and proud. All right, we don't know A, so A is A squared. We do know B, so that's going to be 9 squared. We do know C, so C is going to be 10 squared, or 10, which for our formula, for the purposes, is 10 squared. So now, just like everything else, let's go through and square everything. So we've got a squared plus 9 squared would be 81. B squared, excuse me, 100 squared. I'm saying the answer. 10 squared is 100. So now we've got a squared plus 81 equals 100. Just like in the equation, got to get rid of plus 81. We're going to subtract it. Subtract 81 from both sides. Cancel on the left. That's supposed to be red. A squared equals 100 minus 81, that's going to be 19. So now from this step, we finish just like we did all of them. We finish by square rooting both sides. Square root and square cancels out, and we're left with A. It occurs to me that I didn't actually read the question to really explain in the real world problem what was going on, in case I didn't give you the visual, because I took for granted they gave us the visual. So before I go into real fast, let's interpret this. It says a wire that is 10 meters long, so the wire is 10 meters long, is supporting a utility pole. Or kind of like you see that on the poles, or a flagpole, or on like the power lines. You see a wire sometimes holding the poles up. The wire is anchored to the ground and is attached to the pole 9 meters above the ground. What is the distance from the bottom of the pole to the point where the wire is attached to the ground? Round your to the nearest tenth. They might need to know this, for example, if they're on a construction site, they know they're going to have a pole this high, they know they have to mount the attachment here. They need to decide, well, how much clearance they need to have around it in order to attach their wires, based on how long the wires have to be, how much clearance around that pole do they need to have room for that wire. This could be an example where they would need that. So your visual, as they said, if it was 9 meters above the ground, consider that to be vertical, so just make that up and down. Make the wire, if you're imagining like a support wire, it's going to essentially tying it to the ground, it's going to be diagonal. So that's going to be your hypotenuse, because the vertical and the horizontal will always be your 90-degree angle. That's how you could have drawn this visual on your own if they didn't give it to you already. Alright, sorry for that. So now going back to solving the question, we got to do the square root of 19. That's what we're going to do to find our answer. Now, 19 is between 16 and 25. Those are perfect squares. So it's going to be 4 point something. It's closer to 16 than it is 25, so it's probably around 4.3, 4.4. So get out your calculator. It's okay if you don't know the precise answers. Of course not. These are irrational numbers. Type in square root of 19. So 19 square root, you get 4.35. It said round to the nearest tenth. So we're going to say A is approximately 4.4. So now in this question, it says what is the distance the anchor point is to the pole on the ground. We're going to say 4.4 meters. And that's going to be how far away that wire attaches to the ground from the pole. So at this point, I hope you feel that we've done tons of examples to help you see different types of questions. We did some with decimals, we did some with word problems, and some with not. I want you guys to now know Every single question sets up exactly the same way. Just trust in that, practice it, and you'll see it yourself. And every question is the Pythagorean theorem. Plug in for A, plug in for B, plug in for C. They will always give you 2 of the 3 sides. If for some reason you feel like they only give you 1 side, that means there's going to be a hint somewhere in that question where they dropped a hint how to find the length of one of those other sides. That way you'll have 2 to work with in order to get you now use the Pythagorean theorem to find your 3rd side. So take comfort in that. There's only 2 types of questions. You're either looking for a leg, no matter which leg, it's exactly the same, or you're looking for the hypotenuse. And they both start off exactly the same by plugging in. They both have the next step of squaring everything, but now the difference is what you do to both sides, or no, I'm sorry, what you do after you square everything. Either if it's a hypotenuse question, you know both of these, so you just add them together. If it was a leg type question, you're going to move this to the other side by subtracting. After that, they finish exactly the same. Take the square root of both sides and round, and now you're done. Alright guys, so good luck, practice this, make this one of those skills that you